Okay, so this is one example for the system. So then there is another one example, so that is washing machine. Okay, as I told you, the system will works based on the rules. Okay, na? So here in the washing machine, it is a automatic cloth washing system. Okay, now we can see the parts. Okay, what are all the parts? It has a like a status display panel, switches, dials, okay, motor, power supply and control units, and inner water level sensors, and solenoid valves. So these are the like components which are used in the washing machine. Okay, now so here what are all the rules? The first rule is wash by spinning. Okay, the cloth should wash by spinning. Okay, now so this is the first rule. So because the cloth will not wash when it stop, it's in a like static movement. Okay, so it should always rotate to wash the cloths. Okay, so if it is stop means the cloths will not washing. Then rinse is nothing but removing water maximum water content in the cloths. Okay, na? So this action will be done in the washing machine. So and this should only done after the washing. Okay, not before the washing. Okay, na? So first there should be cloth washing, and then there comes the rinse. Then after the rinse there will be a dryer, so which the hot air will be blown to the like cloths. Okay, next after drying, wash over by blinking. Okay, now so wash over by blinking means like all the excessive waters and in the like waste particles in the washing machine will be flowed out from the like object. Okay, na? So after this step, each step display the process stage. Okay, na? So whether the machine is like spinning, rinsing, drying, so all the status will be visible in the display. That is the fifth rules. Then in the sixth, in case interruption, execute only remaining. Okay, na? So which means, so when one process is taking place, okay, let us take example. So the machine is in level 2. Okay, this state. Now the power gets off. Okay, so automatically power gets off. Then again if the power comes back, then it should start from the rinsing, not washing. Okay, so due to this what happens, so if the cloth is if the machine is in last step, when the power is suddenly off, it will start from first step. Okay, so this should avoid. So when the power is off, after the power is arrived, it should start from the current state. Okay, na? So if it is stopped at the 4th level, it should start from the 4th level only, not first level. Okay, so this is a interruption, execute only the remaining part. Okay, na? So these are the some rules inside the washing machine. Okay, so if the washing machine works according to these rules, then it is called as a system. Okay, if it fails any one process, it is not called as a system. Okay, done. Okay, so and the next topic, that is embedded system. Okay, now so I already told you, so every time you should note down the points. Okay, okay, so the next one is like embedded system. 1 minute. Okay, so already discussed about the embedded system, where the combination of software and hardware is equal to embedded system. Embedded system is nothing but an application. Okay, na? Why are you combining hardware and software means, so you are building an application. Okay, application, product or anything. Okay, so for that you must combine both software and hardware. After this the product will be developed. Okay, na? So now write down this definition, like what are the embedded system devices. Okay, what type of devices are the embedded system. Okay, write down this definition. Embedded systems are the devices used to control, monitor or assist the operation of equipment, machinery or plant. Okay, embedded reflects the fact that they are an integral part of the system. So this is the definition of embedded devices. Okay, now done. So both are same, the definition which you have written in the last time. Okay, so here in the second point you can see embedded is a combination of hardware and software. Okay, to do a specifically designed for the particular function. Okay, like these are simple definitions based on the embedded system. Okay, so here in this slide you can understand combining software and hardware. What are the software? So softwares are nothing but programming languages, applications to write the program and to upload the program. These softwares used for the uploading program comes under the software part. And what are the hardware means? The hardwares are the controllers, sensors, motors, display modules. So these comes under in the hardware. Okay, na? By combining these two, so you are giving an output as an application. Okay, done. Okay, so now here you can see what is inside embedded system. Okay, now so inside every embedded system there will be hardware and software both. Okay, what are all the hardware means? The CPU, memory, IO devices. Okay, and the softwares are like applications, OS, device drivers. These are the basic components of embedded system. So the CPU is the main processor. Okay, na? So the CPU work is to process the input data and control the output devices. Next one is memory. So where the RAM, ROM, so these will be inbuilt connected. Okay, na? So in the microcontroller. So memory is to store the data and programming files. Okay, and any fixed datas. Okay, na? And temporary datas. So these are stored in the memories. Next they are IO devices. Okay, IO devices are nothing but input output devices. So where you will interface with the microcontrollers. Okay, these are the hardware parts. When it comes to the software, the applications. So for the Arduino Uno, you are using the software called Arduino IDE. Okay, na? So this is the software used to program the microcontroller. Then there is a OS. So as you can see in your laptops, there will be various OS systems. Okay, like Windows, Linux. Okay, so these are all the OS. So which you call it as operating systems. Then there is a device drivers. Okay, so what these drivers will do means they helps to communicate between controller to laptop. Okay, na? So you must always install these drivers. Without the drivers, it is difficult to communicate between microcontroller and laptop. Okay, na? So driver helps to serially communicate between controller and the system. Done. So these are the basic components which are used in the embedded system. So here in this image you can see there is a microcontroller, there are multiple IO devices. Okay, these are fully made like a project or a model or anything. Okay, so just you can draw the block diagram of an embedded system, and you can write a CPU or all the components inside that box. Okay, memory, IO devices, applications, OS devices, device drivers, etc. Okay, and then we have computer. Okay, so now we will discuss input output device for the computer. Okay, let us take example of a system. So inside every computer there will be multiple devices. Okay. Okay. So now tell me, so I will build on block. Okay, now wait a minute. Okay, so now I will draw like on system. Just tell me what are all the inputs and outputs. So I am taking an example of a system nothing but a computer. Okay. So, okay. So 1 minute. Okay, so this is the main CPU. Okay, now done. So now tell me what are all the inputs for the CPU. So there will be like first input, I will write it as keyboard. Okay, so keyboard, mouse, so these are the inputs for the CPU. Okay, I will explain in this slide only. Okay, so here you can see like large memories. In the inside the memory there will be a RAM, ROM, caches. So these files will comes under the memory files, and then there is a input devices like keyboard, mouse, scanner. Okay, and many more. So those are called as input devices, and there are some output units like monitor, printer, and speakers. Okay, so these are output devices for the computer. And when it comes to the networking units, there will be like Ethernet cards, drivers. Okay, so Wi-Fi modules, internet, cloud platforms. These are the network units for the system. And then there are the IO units, so which we can tell it as modem and faxcom modem. So these are the devices which are interfaced with the CPU. Okay, na? Yes. Done. So these are some example of computer with the input and output device. Okay, na? So then like what makes embedded system different? That means, so when you compare another type of systems, okay, so in the embedded system there will be like these advantages, you can call it as advantages. So first point is a real-time operation. Okay, so real-time operation is nothing but like it is showing showing the live data, so which comes from the sensor. Okay, let us say you have connected some temperature sensors. Okay, so it will read the temperature. So within fraction of a seconds it will give the output like so now it is showing like 27.8 or 29 degrees. Okay, or else 30 degrees. So like this the value will be shown exactly with the live values, live data. Okay, so that is called as real-time operation. So when I can give one example like telecast, live telecast. Okay, na? So now you can watch like games. Yes. Who is that? Okay, na? So live telecast comes under the real-time operations. Okay, na? So here the live data will be shown. That's why we call it as real-time operation. Next, size. When it comes to the size, the embedded system are very small in sizes. Okay, na? So as compared to this microprocessors and all, controllers are very very small in the sizes. Next, cost. So embedded system cost is very less. If you take an example of an Arduino, okay na, so Arduino you will get around like 600-650 rupees cost. Okay, so due to this it is a very small low cost device. Then time. So here the to process the data. Okay, so the as I told you in the example, temperature sensor. So it will take the temperature analog values from the temperature sensor, okay, and it will process it, and it will calculate this, and then it will give the temperature value. Okay, so it will take very little time to process the data. Okay, process the data and it will give the output. That's all. Okay, speed is more. Next, reliability. Reliability is nothing but a lifespan. So as an embedded system device, it will work on the longer period. Okay, na? So it will not get damaged easily. We can use it for long years or days or anything. Okay. Next, safety. So as it comes to the safety purpose, so here in the microcontroller we use only small voltage, like DC around 12 volts. Maximum is at 12 volts. Okay, na? So we will use only 12 volts. So since it is a DC, there is no shock or any other emergency situations using this microcontroller. And also no one can hack the embedded system, because there is no network connected to the embedded system. Okay, so it is offline. Okay, and serial communication. So no one can hack it, and they can take the data. Okay, now. Then energy. So energy means, so these are small devices will consumes less energy. Okay, not more energy. So these needs very less energy. We can power the microcontrollers using a small battery. Okay, either it can be 9 volts or 5 volts, 12 volts. Like this battery, you can use it and you can connect it to the microcontroller. Okay, then security. So when it comes to the security part, there are multiple softwares, so which strictly prohibits the third-party servers. Okay, so these are the security chances in the embedded systems. Okay, now. Okay, so here you can see there are classification of embedded system. Please note down these types. These are the classification of embedded system: small scale embedded systems, medium scale embedded systems, and sophisticated embedded systems. Okay, write down this. Okay, so when it comes to the small scale embedded systems, so here what happens, the ICs, so these are the ICs, we call it as DIP package. Okay, now, so DIP package. So here there are two side pins. This is one side, this is one side. Okay, that's why it is called as dual in package. So this is black color is called as a package. Okay, no, dual in package, we call it as dual in package. So these type of ICs are used basic level of embedded systems, and these are the old versions. Okay, so you already know about 8051 IC. Okay, So these are like dual in packages where the speed is very low. Okay, uh, like 8-bit to 16-bit microcontrollers. This is the speed of the microcontroller. Okay, note down these technical points. So it has only 8-bit or 16-bit microcontroller bit speed of communication. Okay, now data processing speed. Next, so it has little hardware and software complexity. So when you compare it to the different types of microcontrollers, so here the hardware and software complexity is very less. Okay, and they may even be battery operated. Okay, so you can use a simple battery and you can power the ICs. Okay, that is also possible in a small scale embedded systems. Here the programming languages like C, C++. Okay, so usually C is used. Okay, but so inside that there is the assembly languages, C++. Okay, C languages. So, and the programming tools are like editor, assembler and cross assembler. These are the programming tools, so where you can program this type of controllers. Okay, so here you can write simple program, compile it and you can upload it to the controller using these tools. So small scale means it has a very low speed. Okay, and then these are the basic and old version of design of microcontrollers. Okay, now so the next one is medium scale embedded systems. So these are like 16 or 32-bit microcontrollers. Okay, they are also called as digital signal processors. Okay, or RISC, reduced instruction set computers. Okay, now so these have more number of hardware and software complexity compared to small scale embedded systems. Okay, and the programming tools here, so you can use the tools like RTOS. Okay, so real-time operating systems, we call it as real-time operating systems. Then there are like multiple applications like source code engineering tools, simulators, debugger and integrated development environment. Okay, so now in the Arduino, using the Arduino Uno board, we are using integrated development environment. Okay, we also call it as Arduino IDE. Okay, IDE means integrated development environment. So where you can write and upload the program to various types of microcontrollers. Okay, like Arduinos, ESP32s and many more, STM32s. Okay, so there are multiple and different types of controllers. You can select that board and you can write the program and you can upload the program using the Arduino IDEs. Okay, so these are the medium scale embedded systems. Then there are sophisticated embedded systems. So here the hardware and software complexity is enormous. Enormous means huge software and hardware complexity. Okay, so hardware and software complexity is more, and also the processor needs scalable or configurable processor and programming logic arrays. Okay, without this you cannot program these controllers. So mainly these type of controllers are programmed by the manufacturer itself. Okay, it cannot be programmed or modified by the third parties or like customers and all. Okay, so it is only programmed by the manufacturers. Okay, so and constrained by the processing speed available in their hardware units. Okay, so these type of embedded systems can be of high speed data communications. Okay, so these are available on the different types of you can check it in the online. Okay, next, programming tools. So here it cannot be programmed by the users, and here what it tells means for these systems may not be readily available at a reasonable cost or may not be available at all. The compiler or retargetable compiler might have to be developed for this. Okay, so since this is of manufacturer preferred, so you cannot program this controller. Okay, it will be only programmed by the manufacturer itself. Okay, then there are some embedded processors. So inside embedded system, there is not only microcontroller, there are some microprocessor also. Okay, so here the special microprocessor and controllers are often called as embedded processors. These special microprocessor means they are used for the like advanced type of project in the embedded system. Okay, advanced type means in aerospace, okay, rockets. So here you can see these processor and all, which they require very much high speed data communications and also like less chances of failures. There we will use the processor and all. Okay, now. Okay, and also an embedded processor is used when fast processing, fast context switching, and atomic ALU operations are needed. Okay, na? So here the processor types of processors, for example, so ARM7, okay, and Intel i960. This is also processor, okay, not a microcontroller. These are all the processors. Then AMD 29050. Okay, so this is also a processor. Okay, now. Okay. So then there are some advantages. So advantages and both are same. Okay. So first point is like easily customizable. Okay. So when you already done a project in embedded system, so just I will tell you like that add one sensor. Okay. So if you have done the project for only temperature, I will say like add humidity sensor, add motion sensors, okay, add gas sensors. Okay, so you can easily modify the completed embedded systems. Okay, now it is not there will be no difficulties. You can simply add the sensor and modify the program, and you can upload it to the controller. Okay, simple. So that's why it is called as easily customizable. Then low power consumption, since it is like small size, the power consumption is very low and it is low cost. Okay, na? Then it has a enhanced performance. Okay, na? So since it is used for only specific task, okay, not a multiple tasking. So since we use it for only specific task, here the performance will be very high. Okay, na? So then there are disadvantages like high development effort. Okay, so if you are like going to invent any product or any project in the embedded system, the development effort is more. Okay, why means the time to invent and testing and research will take more than a year, okay, to develop an embedded system product. Okay, na? So here we need a testing department, manufacturing department, okay, and hardware PCB designing. So these type of teams we require to build an embedded system product. Okay, that's why we need a high development efforts, okay, high investment. Then larger time to market. So why means whenever you invite embedded system product, okay, na? So the customer should buy that product. After that they use it. After that they review it. If the product is good, then your sales will go high. Okay. When the product feedback is low, then the market will be down for that product. Okay, now that's why it takes larger time to market. Okay, so you should only release the product to the market when it's fully ready and with hundred of times of testings. Okay, without that it is not possible. Okay na? So these are the two disadvantages about the embedded system. Then we have the applications. Okay, so these are the applications of embedded systems, like in the various domains. Okay, first there is a household appliances. Okay, these are the household appliances: microwaves, ovens, television, DVD players, and recorders. Okay, so all these will be inbuilt with the embedded systems. Okay na? Then there are audio players. Audio players are nothing but like sound amplifiers, home theaters. Okay, next is integrated systems in aircraft and missiles. Okay, so in aircrafts and all, so we required like vast area of embedded system products. Okay, to control the flight amplitude, engines, okay, air pressures. So they keep the aeroplane in the stable. Okay, so for all this we will use the embedded systems. Okay, and to detect the vehicle, any objects in the airs. Okay, using the radar systems. So these are all embedded systems. Okay, when you like in the defense sectors and all, missiles will be aiming towards the like opposite teams. Okay, so when you aim that location and you release the missiles will go and place it in the like aimed locations or destinations. Okay na? So this is only possible using the embedded systems. Okay, next is cellular telephones. So in olden days we have used like telecommunications. Okay, with the wired communications. So these comes under these cellular telephones. There also embedded system is used for receiving and transmitting the voice commands. Okay na? Voice informations. Next, electric and electronic motor controllers. Okay, so these are used in the like elevators. Okay, lift and all. The motor will move sometimes for the forward and sometimes for the reverse. Okay, and sometime it will stop. So these all operations will be done using the motor drivers. Okay, in that motor driver the embedded system products will be used. Okay, that's why we call it as applications under the embedded system. Next, engine controllers in automobiles. So here what happens, to check the oil levels, okay, in the engine, oil temperature, okay, and also service indication and any fuel leakage. So for all these there will be a sensors. Okay, and these sensors data will be given to the controllers, and that data based on that data, so you can see it in the dashboards of the vehicles. Okay na? So then there is calculators. So your normal calculators are used with the built with the embedded systems, microcontrollers. Okay na? Next, medical equipments. So as you see in the hospitals and all, there will be like multiple devices. Okay, ECG machines, X-ray machines, okay, CG. Okay, so all these devices are inbuilt with the embedded systems. Okay na? And heartbeat sensors, okay, BP. So these all the values will be written by the embedded system devices. Next, video games. So video game used for the devices which are used for the like particular task, like video games and all. In that the microcontroller are used, and also digital musical instruments. Okay, and these guitars and all. The microcontrollers are used to amplify the sound and musics like this. Okay, there are also present the embedded systems. So these are the like basic introduction about embedded systems. So now we will discuss about the types of embedded systems and also difference between microcontroller and microprocessors. Okay now. So write down these applications, all of you. So these are the main applications of an embedded system. So if you understand these application means, then you can easily understand the embedded systems. Okay. So now the two more concepts are types of embedded systems. Okay now. So I will not present any presentation PPTs based on the topic. Okay. So just I will discuss. Okay now. The first one is like real-time systems. Okay now. So real-time systems, in that, so we can say hard real-time and soft real-time. Okay now. So I can just write down these definitions. I will tell you. So write down the topic as hard real-time systems. Okay. So for the hard real-time, write down the definition. A hard real-time system is one where missing a deadline is a totally system failure. A hard real-time system is one where missing a deadline is a total system failure. Okay. So what it tells means, so when an embedded system fails, so I already explained you about aircraft, missiles and all. So think about a aeroplane is flying above 1000 meters above the ground surface. Okay. So if any parts fails, embedded parts fails, what happens? The aeroplane can crash. Okay now. So these will comes under the hard real-time system. If any one system fails, all total systems will be failed. Okay, there will be chances of life, death, or any severe damages. Okay, and huge financial losses. So these will comes under the hard real-time. Okay, so another one example is like a airbag. Okay now. So if airbag is not opened after the accident, then the driver may get death or severely injured or hospitalized like this. Okay, so this is also one condition. And also one more is nuclear reactor control. Okay, so this will also come under the hard real times. Okay, where very minute failures are expected. Okay, so there will be multiple testings when it comes to the hard real time. Okay, so where the failure chances is minimized 0.1%. Okay, so those are called as hard real time. Okay, so you can write down the characteristics of a hard real time. So what it tells means, deadlines are strict and absolute. Okay, so in the hard real time, these are the characteristics. Okay, deadlines are strict and absolute. Next point, predictable deterministic timing. Okay, usually uses RTOS with priority based scheduling. Okay now, usually uses RTOS with priority based scheduling. Next point is, failure can cause catastrophic results. Catastrophic result is nothing but a huge losses. Okay now, and the examples I already told you, aircraft flight controls. Okay, so where all the aircraft components should work exactly. Okay, without any failures. Okay, if any one sensors or any one module fails, means the total system will be failed. Okay now, this causes more dead bodies. Okay now, so to avoid this, so in the hard real time, it is necessary to test the components multiple times. Okay, so here in the next is soft real times. Okay now, so these are opposite of the hard real time, what it tells means, just note down the topic soft real time systems. So inside that this is the definition. Okay, write in the definition. A soft real time system, a soft real time system is one where missing a deadline. A soft real time system is one where missing a deadline degrades performance, comma, but does not cause total failure, but does not cause total failure. Okay, so here what happens, so before this, write down the characteristics. Inside the characteristics, first point, deadlines are important but flexible. Deadlines are important but flexible. Okay, now occasional deadline, next point, occasional deadline misses are acceptable. Okay, now next point, focus on average response time. Focus on average response time. Okay, fourth point, system continues to function. System continues to function. Okay, now okay, so what is the soft real time means? So I will give just an example. Okay, now so take an live video streaming. Okay, live video streaming, if any network issue, then what happens, the video will blur, okay, or else the clarity will be reduced, or else the video is stuck. So after sometimes it will be in a normal condition, but at some situation point it will act like this. Okay, so this can be acceptable. Okay, there will be no chances of any death or any severe damages, any financial damages or anything. Okay, so when it comes to that type of losses, we call it as hard real time. So if that is not considered, then it is called as a soft real time. And another one example, so let us consider you have done the project on home automation. Okay, now home automation, you are controlling the bulbs, fans using your mobile phones. So there is another option to control the fans and lights, that is switch. Okay, manual switch. And also another option is to control these devices using your mobile phones. Okay, now so if embedded system fails, so when if the fan is not controlled by the mobile phone, not controlling from the mobile phone, you can just go near the switch box and turn off the fan. Okay, there is an option. Okay, so that is called as soft real time. Okay, so where the failure is not mattered much. Okay, and another one example is printer spooling. Okay, so when you are printing a document, okay, printing a color, you are just given the paper to the color printer, and there is some paint or color placed in the sheets, okay, on the letters and all. Okay, so you can just throw that paper to the dustbin and you can place it a new paper, and you can just clean that roller, and you can print the again print the document. Okay, it is possible. Okay, so here if the embedded system fails, you have another option, that is called as soft real time. Okay, so when there is no option, it is a deadline. Okay, so you have only one way, that is called as hard real time. Okay, so these comes under in complex, more complex devices like aircraft, rockets, space jets. Okay, here done. So this is the difference between hard real time and soft real time. Okay, so if you have any doubts in these two topics, you can ask. Okay, so hard real time and soft real time. Understood? Okay, So then we have like two components in the embedded system. Those are like microcontrollers and microprocessors. Okay, now. So what are the microcontrollers? Can anyone simply like just put a message or like unmute your call and you can speak? What is a microcontroller? Okay, so the basic definition of a microcontroller is write down the topic microcontrollers and write down the definition. A microcontroller is a single chip. A microcontroller is a single chip embedded system. Single chip embedded system that contains everything needed to control a device. Contains everything needed to control a device. Okay. So everything means what are all the components? So inside the microcontroller, you can see the CPU, which is a processing unit, and the RAM, which is a data memory, ROM, which is a program memory, okay, and IO ports, where you will connect different types of devices. Next, timers and counters. These are all inbuilt in the microcontrollers, okay, and also serial interfaces, ADC, DAC, okay. So these will be inside the microcontroller. That's why it is a single chip. Okay, it is called as a single chip, where all the devices will be inbuilt. Okay, the memory and all. Okay, now. So when it comes to the microprocessor, all these will be externally connected. Okay, now. So just note on this application of a microcontroller. Okay, now. So in the microcontroller, you can see various devices. So which are like 8051. So this is a microcontroller, and AVR Atmega. So this is also microcontroller, and ARM Cortex M. This is also microcontroller. Okay. So and the applications. So applications like washing machines, microwave ovens, remote controls, okay, automotive control units, IoT devices. These are the applications of the microcontrollers. Okay, na? So then you have the processor, microprocessor. Okay. So it is a opposite of a microcontroller, where all the devices are externally connected. Okay, na? All the devices are nothing but like RAM, ROM, okay, like the devices. Write down the definition of processor. Write a topic like microprocessor. Write down the definition. A processor is mainly a CPU on a chip. CPU on a chip. Full stop. It does not include memory or peripherals on the same chip. It does not include memory or peripherals on the same chip. Okay, now done. So here RAM, ROM, IO devices, timers, interfaces. So these are externally connected. Okay, not internally connected. These are externally connected. Okay. So here these are the types of microprocessor. You can note down. Intel Core series. These are the types of microprocessor. Okay. First one is Intel Core series. Next one is AMD Ryzen. AMD Ryzen. Next one is ARM Cortex A. So in the microcontroller we have written ARM Cortex M. That means that is a controller. So ARM Cortex A, nothing but a microprocessor. Okay, na? And the applications. So the microprocessor are used in the applications like called computer, laptops, smartphones, tablets. Okay, so these are the applications. Okay, na? Next. So next is the difference between microcontroller and microprocessor. So we discussed very large number of points from the microcontroller and microprocessor side of. Okay. So now when it comes to the integration, okay, you can write down two columns. Okay, one is for microcontroller and one is for microprocessor. In that, in the first point, that is integration. Okay, so integration means nothing but a like combination. Okay, in the microcontroller there will be a combination of CPU, memory, IO. Okay, in a single chip. And when it comes to the processor, there is only a CPU in a chip. Okay, all the things like memory, IO pin, IO timers, counters, these will be externally connected. Okay, na? So this is the difference when it comes to the integration. Next, external components. Okay, so in the microcontroller there will be very few external components, but in the processor there are many external components. Okay, next, power consumption. Microcontroller is very low power, where the microprocessor is high power consumption. Okay, and when it comes to the cost, microcontroller is a low cost, processor is high cost. Okay, next, speed. When it comes to the speed, microcontroller is moderate and like medium speed, and the processor is very high speed processing. Okay, and applications. So microcontroller is mainly used for the embedded controls. Okay, and processor is used for the general computing, or else you can write it like specific task. Microcontroller is used to do a specific task, processor are used to do a general purpose work. Okay, specific task and general purpose. So these are the like basic difference between microcontrollers and microprocessor. Okay, na? So there are multiple difference. So you can just go through the microprocessor and microcontroller topics. So there will be a lot of difference between microcontroller and microprocessor. Okay, so you can check it in the online ChatGPT or anything. Okay, na? So I will give some assignments based on this today's class topics. So tomorrow you should before tomorrow class you should write down in the notebooks. So I already told you should maintain one notebook. Okay, na? So inside that all the assignments, so I will give the assignments daily in the class, or else I will upload it in the Google Classroom. Okay, once again I will share the Google Classroom code. So I already shared the invite link in the group. Okay, you can join it to that classroom, and there I will give a driver link. Okay, to that driver link you should upload the assignments, written assignments. Okay, so written assignments, make it PDF and upload it to the drivers. Okay, I will check it regularly. So if anyone not uploaded the document means, so I will consider it as a absent or anything. Okay, so that's why check the questions in the Google Classroom, just solve those questions and make the PDF and upload it to the Google Drives. Okay, that's all. And one more thing, so in your VTube portal, so when it comes to the summary, okay, so you should write summary of the today's class, what are all the topics we have discussed, that is the summary. Okay, so after that it shows time. So time duration, we should select 8 hours per day. Okay, so you should work 8 hours a day. There will be like 1.5 2 hours online class, okay now, and 2 hours for your assignments, and 2 hours the class task. What are all the topics I have given, I have discussed all the topics. You must prepare the documents. Okay, this is a 2 hours. This is a daily working schedule of you. Okay, so you should enter 8 hours daily in the V2 website. Okay, then again 2 hours for the project or related to embedded system or other topics, okay, or EV related topics. So you should go through the latest news updates about the electric vehicles. Okay, so this is also a task. Okay, total there should be a 8 hours work every day from your side. Okay, okay now. So if you have any doubts related to the topics from the initial stage and till date, any doubts related to the technical or any doubts on the internship or class or anything? Okay, so and I will take attendance in the daily class. Okay, so if anyone is absent, okay, so they will be considered as a absent, and you should follow the attendance. If the attendance is shortage means, so they should pay the fine and all. Okay, so that is already updated for you in the WhatsApp group. Okay now, so that's why maintain attendance daily. Okay, okay, so I will call the attendance, answer it. Embedded EV.